Hello, everyone. I hope you all are having a good day today. My name is Vance Morgan. I can't do my usual overlay where it'll have me on there, kind of like a Twitch stream or something. But we'll go ahead and get this started. We'll do it just a regular presentation here. Let me share my screen for you. So today I want to talk to you about version control. You can also call this source control. The terms are pretty much interchangeable. There's some nuances between them, but for our purposes, it's pretty much the same thing. Most people just use it interchangeably. So how can multiple developers simultaneously work on the same code base without having conflict? And I promise you, these clowns on NCIS that are hacking or whatever they're doing, that's not how you do it. You don't jump on the same keyboard, obviously, but y'all might get a kick out of that. So what is version control? Well, first of all, it's widely used by nearly all professional developers and teams. I don't care if you're on working for a software company like Google or Microsoft or Amazon, or you're working for a university doing research, and even individual developers working at home in their spare time as a hobby or professionally. There's solo developers out there working on apps for iPhones or Android. They're using version control. I almost guarantee you, almost everybody is using some form of version control. It doesn't make sense to not use it. So what does it do? Well, it manages all the changes to your source code over time. It tracks all these changes for you and allows you to go back and see every change you've made, undo changes you've made essentially, and it provides for parallel development by multiple developers, which is extremely powerful. And because most software development teams are large, projects get pretty big, and trying to manage everybody working on the same code, it can get kind of crazy. It encourages code experimentation. It speeds up development time, and it's occasionally used by non-developers. You don't see it a lot because it's a kind of a technical tool with a lot of little details to it, but it does get used by some non-developers. So these are common version control concepts that kind of apply to most version control. Now, I will say that this presentation is more towards distributed version control, mainly Git. So the concepts might not map exactly to all forms of version control, but these concepts are basically there in all of them. Change tracking, committing, revisions and change sets, push and pull, diffing, branching, and merging. Now we're going to go ahead and dive into these. It's not going to be a deep dive, but we'll kind of cover the basics of these topics. So change tracking, what is change tracking? It's basically a better undo. And anybody that's used something like Microsoft Word or Adobe Photoshop, you're familiar with undo. You make some changes, you can go back and undo your last changes. Some applications provide a more detailed form of undo. I know Adobe Photoshop, you can see actions that you've done, and you can undo actions without undoing your previous action. You can undo an action farther back. It's a little more complicated. You can do more powerful stuff, but for the most part, it's pretty simple. You open a file, you edit the file, and when you save it, any changes you've made during that process are gone. It just has the new saved file. You can't undo when you reopen that file. Now, I realize there's things like cloud storage with OneDrive, and using Office products, you can do some undo even after you've saved it, and it saves continuously. But for the most part, most programs, if you edit the file and then you save it, close it, when you reopen it, it's a blank slate. You can't undo anything. Change tracking in version control is different. It is more controlled because it doesn't just track every change you make until you actually tell it to, hey, save these changes. But it keeps track of all those changes forever, and it tracks it for multiple files and folders. It's not just one file, it's all the changes, and you can group those changes into one single big change. And it's a very powerful feature because a lot of changes you make in several different code files are all together. You don't want to separate those changes as separate things for each file. It's one cohesive change. And that feature is super important to solar developers. You can imagine if you're working on a big project solo, it's just as important for you to be able to track all your changes and go back and see what you've done later on, especially when you might work on a project for as consulting work and you haven't looked at that code in a while. You can go back and then look at that code and kind of review some of the last changes you made. It's a very powerful tool. This can also be used by authors that want to keep track of revisions to a book. Now, I will say you're probably not going to see most your typical language arts type people working on their book in Git or in a version control software, but you will see programmers and other technical type authors writing technical documentation, that kind of thing, and they will be putting that inside of a version control system. That way they can make changes to it because technology changes and they have to constantly update their literature, their work, and they can keep track of those changes and fix problems and go back and undo mistakes if they've introduced something that's not right. So following on from that, we go to committing, and this goes right in with change tracking. When you commit to your repository, that means, say you have several files and each one has a common variable, or it's references a class, an object, a class name, and you want to change that name. Well, you might have to change that name in a whole bunch of different files. Well, say you make that change, and then you want to tell your version control software that you've made that change and you want to track that. Then you commit those changes to the repository. By default, it will do it to your local repository, so it doesn't actually impact anybody else. It's just for you, but it does keep track of that. And as I said, you group those changes together, changes of multiple files, all grouped into one cohesive change. The general rule of thumb is to commit early and often. I would not recommend that for relationships, but in version control, it is very important. You want to make sure every time you make a single change that can stand on its own, commit that. You refactor by changing a class name. Once you've changed it, commit it. You modify a function, commit it. Every single change needs to be committed. And that's important because later on, when you want to go back and look at things you've changed, you see each little change you've made all as one little piece, and it's broken out from other changes. So it's easy to see that change in its own light. And it's important whenever you do make you commit those changes that you add a comment. It's kind of commit and comment. You want to comment on the commit to make sure you have a little bit of information about why or what you were doing, what this change was. It might be as simple as renamed this variable, but usually want to give a little bit of detail so you kind of see what's going on there when you look at it a year from now. So revisions and change sets build on your commit. When you commit these changes, it's stored in the repository as a change set. And that change set keeps track of every file and folder that was changed, and it gives it a unique revision number. Now, some version control systems will give it an incremental revision number, and that's more for your centralized version control. And something where it's decentralized, it can't really do that because everybody's making commits on their own repositories, and those get all pushed to like a central another repository that they're all kind of sharing. So in a sense, the revision just ends up being a globally unique identifier of some form. It's random, but it shouldn't ever, conflict with somebody else's. It should always be random and unique. But these revisions make it easy to refer to the change set later. So you're working on fixing some bugs or whatever, and you're talking to a colleague and you're like, hey, you need to go look at this change set. Here's a revision number so you can see what I'm talking about. And they can go back to the exact same change set that you're talking about. No confusion. So every change set includes details like who made the changes, what changes they made, like what files were changed, and even what was changed in each file, when the changes were made, and then the comment of why those changes were made. And It's obviously important for collaborations. There's even a thing called blame. You can go back and see who made this change that introduced a bug. Oh, we know we gotta blame Andy over here. He's always making these errors. Sorry, Andy. Then we get to push and pull, and it kind of builds on these change sets. When you committed changes to your local repository, how do you then update a remote repository, either a colleague's or an agreed upon central repository? Well, you push those changes from your local repository to the remote, and that pretty simple. You push and pull the exact opposite. You're pulling in changes from a remote repository to your own repository, your own repository. Getting tongue-tied here. And pulls should be done frequently because you want to always make sure you're working off the most recent updates on the remote repository. If everybody's kind of working on your project on GitHub and they're all making changes to it and things are getting pushed to it, you want to make sure you're getting those most recent changes so you're not ever out of date from what everybody else is working on. But there's some interesting features that I'm going to get to later on that allows you to not be interrupted by those other people's changes. So it's very good to keep your local repository updated. It reduces conflicts when you're performing a push, which I'll get to in a moment. And it's important to know that push and pull are very efficient. Your local repository includes an exact copy of the remote repository. But when you do a push or a pull, it's not sending all of your repository out. It's only sending the deltas or the changes that have actually made. So conflicts, which I mentioned before. Conflicts happen when two or more people have made changes to the same code and perform a push without having each other's changes in their local repository. That's kind of a complicated sentence, and I'll kind of explain it in a little scenario. Jack and Jill are both working on the same project. They both just did a pull. Their local repositories are up to date. And Jack starts working on the code. Jack's kind of slow. He's working on a little bit today, a little bit tomorrow. It might take him a week to finish what he's working on. Jill, however, she just had a few changes to make, and she made those changes and then committed them to her local repository. And then she went ahead and pushed them to the remote. Well, now Jack, a week later, he doesn't know about those changes that Jill pushed to the remote repository because he's lazy and he never did a pull. So now when he finally goes to push his changes, he may have touched, if he modified a file that she also modified, when he tries to push it, it's going to say there's a conflict because he did not take it in account to the changes she made when he made his push. So there's two ways to solve this. One, he'll have to merge his changes with hers, or two, one of them wins out. And the thing is, the person that has the conflict is the one that has to deal with it. She's already pushed her changes. It has nothing to do with her. The remote repository is fine. The person that is having the conflict, they're the ones that have to deal with it. In a situation like this, it's important to communicate with your other team members to make sure you know what's going on. That way you reduce these problems. And if you're both working on the same file at the same time, it's definitely important to make sure you're both tracking. You're both on the same page. So diffing is not really necessarily part of version control itself. It's usually a tool that in your development environment, most every development environment, even lightweight code editors, will often have some kind of a diffing tool. But it's a way for you to visualize the difference between two revisions of the same file. It's very helpful for doing merges, figuring out how to merge the changes that you made and changes somebody else made. It's very helpful for debugging. Maybe something changed recently and you introduced a bug. Well, if you visualize the diff, you can see exactly what has changed from when it was working to when it's not working. So here's an example of a diff. On the left, you see some of my own code before, and all the red highlighted areas, those are lines that have either been deleted or changed. And on the right pane, you will see the same file after it's had changes made to it. Everything in green is something that's been changed or added. And if you notice, it's smart enough to track how line numbers change because there's a lot more code on the right than on the left. So on the left, it puts in holes or puts in blanks. And you'll notice, take line 15 on the left, which corresponds to line 15 on the right perfectly. But if you go down to line 18 on the left, on the right, it is now line 22, but those still match up. It's just code was added before it. So the line numbers have changed, but it still knows which line we're tracking here for the diff. Diff is a very handy tool. And now we're going to get to what I consider the most powerful feature of modern day version control systems. The change tracking that I mentioned before, that's okay. That's also that's most important. You have to have that. But branching and merging is the most powerful. We'll put it that way. It allows you to have separate branches that branch off from your main programming, your main source code, and you can experiment with that. You can work on features. You can do whatever you need to do with that, and it does not affect the other copies of your code. You can do whatever you want to with it. You can work on it and then not even decide you don't like it and just drop it and get rid of it. But it does not actually affect your main code. Changes in branches, once you like them or whatever, you want to incorporate that into your development branch, you can merge them right back in. Like I said, it's great for experiments. Working on features, you'll often have developers assigned to a feature. Well, if they're trying to work on a feature while your other developers are changing some of the main product, it might interfere with their feature development. Well, when they make a separate branch, neither of them are going to affect each other. Neither branch affects the other until they finally decide to merge it back together into the main branch or into the development branch. Then they can worry about how those interact. There's several patterns for doing branching and merging. Not really going to go into all those. I'm not an expert on it myself, but here's just a visual representation of some branching and merging. You'll see on the left, you'll see a list of the names of several branches, and from left to right, that's as time is passing. So on this particular case, development branch, the develop branch is the main branch that all your development's being done in. You write code in this, and then when it gets good and ready, you think it's almost ready for production, then it gets merged into the release branch, and that's where final testing is done. And once it's cleared, final testing, everything's good, then it gets then it gets merged into the master branch, and it gets a tag added to it with the version number. It's important when making changes to that release branch that those changes are then merged back in to the development branch. And I'll touch on that in a moment when I kind of talk about hot fixes. So in this particular case, we have a master branch and a hotfix branch. Now, let's say in production, we're on version 0.1 and there's a critical bug. This is a security flaw. Hackers can use this to potentially trick customers into giving away their information. We don't want that. It's got to be fixed now. This can't go through the regular development channels. It's got to be fixed and tested and pushed right back into production. So you'll see them branch off from master into a hotfix branch. They'll work on it, test it, and then they will merge that back into the master. Now, here is an important aspect of this. They also have to merge from that hotfix into the development branch. And here's why. You may have heard of regression bugs. That's where you have a bug that gets introduced, you fix it, and then later on that exact same bug comes up. There's different reasons why you have a regression, but in this case, it's the actual bug just comes back up because if you don't merge the code from your hotfix into your development branch, down the line, when you do merge your development branch back down into master, it won't have that fix in there, and bam, you just reintroduced the same bug you fixed, 6 weeks ago. You don't want to have that. The other thing I want to talk about is the feature branches down here. You can see where they kind of occur separately. Development can happen on those independently from the development branch. But then if a feature is complete and it looks good, they can merge that right back down in development. But branching and merging just allows you to work on the code in parallel, separate teams, however you want to manage it, and not influence each other. It doesn't matter what happens in another branch. Your branch is completely separate. Unless you merge them together, they can happen in parallel without any conflict. Uh, Another important aspect on distributed version control systems like Git, that's most popular right now, I would say. Every local repository, you can create as many branches as you want locally. And when you go to push your changes to the remote repository, you don't have to push those branches there, and you normally won't. So you can do multiple branches for your own experimentation. You have an idea for something, and this is going to be a radical change. You go through and make all these changes. You work on it for several hours, and you realize, oh, this isn't going to work. It's no big deal. You were just working off of this branch. Just ignore it. Don't have to worry about it anymore. You go back to working on the regular development branch, and you don't have to push those changes to the server. Nobody even sees that you were messing with that. You can push those to the server, and sometimes people do want to keep track of these little experimentations and things, but it just depends on however your company or organization wants to handle that. I keep saying server, even though it's decentralized. We sometimes think of it as being a server because you might use a central place to store your repository, like GitHub. But it's not necessarily an authoritative source. Every single repository is just as important. They're all equal. So it's actually a good thing. If you lose your main repository, anybody's computer with that repository locally, that repository can then become the master repository, because there's not a master repository. So and that brings me to the types of version control systems. We have centralized, which is a client server. That's the old traditional style. Subversion is a popular one. Microsoft Team Foundation Services, which that they've kind of moved away from that towards Git now, but that was definitely a popular one for a long time. And on a client server system, the client is the authority, or excuse me, the server is the authority. Everything you do, everything you interact with that code is all through that server. You check out code from the server, you work on it, and you check it back into the server. Branching and merging, you can do it, but it's more difficult because every time you do a branch, it has to copy the entire repository into that branch. It's crazy. It's not very popular anymore. Decentralized or distributed version control or peer-to-peer is just how it sounds. It's every single system has its own repository and they're all equal. You might agree to use one central location to host it, like GitHub, but otherwise every repository is equal. Git is by far the most popular. It was created by, I'm going to probably pronounce his name wrong, Linus Torvalds. He is the creator of the Linux kernel. So almost every server out there serving web pages, whatever, a good vast majority of them anyways, are running Linux. So this guy is a brilliant guy. When he created Git, he knew exactly what he wanted to do for software development, how to make it easier and better for large teams, because Linux's kernel is developed by tons of developers. GitHub is probably the most popular place to store your Git repository. It's very popular for open source projects, but you can also use it for closed source projects. There's others, Bitbucket, Microsoft DevOps for their Azure computing platform, cloud computing platform. But in fact, Microsoft actually bought GitHub, but it's kind of thought of the social media for nerds, for computer geeks, because it's where all the source code is. It's amazing. You can go on there and jump in and join an open source project, and you can start contributing to it. It's just so powerful. I absolutely encourage you to experiment with version control. I would suggest trying to learn some Git. It's a great system to learn. Use it for your own projects, for your own assignments in school. If you have a group project, man, I'm telling you, it will make it so much easier. It keeps everybody on track. You don't have to sit there and email files back and forth or try to share them through some cloud storage. Instead, you all have your own repository. You update, you make your changes, and then you push those changes to something like GitHub, and it just keeps everybody from stepping on each other's toes, and it's so much cleaner and so much easier to work with. So just a quick recap. I know this went longer than our other presentations. I tried to cut it down short, but I'm a little long-winded. I'm sorry. But just a quick recap. Version control is useful when solo and while on a team. It allows developers to keep a complete history of all their changes. It reduces development time and conflicts, and it provides powerful branching and merging, which allows for parallel development of separate features. There's just so many things you can do with version control that will help you as a software developer, whether it's research or no matter what field you're working in. And I will just say, computer science is an interesting field because it's not the study of computers. Computer science is one of those cross disciplinary fields that touches every other field out there. So it's not the study of computers. It's helping solve problems, and it just happens to use computers to do that. But obviously, I can't answer questions. But I hope you all got something out of this, and I hope you can use this in your own work for school and in the future. I'm telling you, if you already know version control systems and you know how to use them, it will help you when you're out getting a job because you're already familiar with it. You know how it works. That's one less thing they have to try to teach you. Now you're still going to learn the ins and outs of how they do it there, but it gives you a little leg up. So thank you very much, and I hope everybody has a great day.